And then just a little reminder, sinusoidal doesn't mean only sine. It's just graphs that have that wave that look like sine graphs. So cosine graphs are sinusoidal graphs as well. So sinusoidal applications would be sine and cosine application problems. The Ferris wheel is like the real typical example of a sine or cosine application problem. So pretty common for you guys to see those problems, but there's other problems as well. So it says, as you ride a Ferris wheel, your distance from the ground varies sinusoidally with time. You are in the last seat filled, and the Ferris wheel starts immediately. Let x be the number of seconds that have elapsed since you got on. You find that it takes you 6 seconds to reach the top, 84 feet above the ground. The diameter of the wheel is 80 feet. You got on the Ferris wheel 4 feet above the ground, and it rotates at a constant rate. Okay, so we're going to sketch a model of this situation, and this doesn't mean the sketch is just to kind of understand, like, if we're looking at a cosine graph or a sine graph, like which equation would be easier to write, because we know that you can always write a sine equation or a cosine equation. It doesn't really matter which one you write, but usually there's one that's easier to write. Does that make sense? We could always write both, but one's usually easier. So we sketch something not to draw an accurate graph. That's why there's no grid here. I'm not really caring if you guys are going to draw something that has actual points that are on a grid. We're going to sketch it so we can figure out what equation would be easiest to write. Maria, go ahead and put your cell phone away. Thank you. All right, so if you think about what happens when you get on a Ferris wheel, how many of you guys have ridden a Ferris wheel before? A couple people? We know what a Ferris wheel is? Okay. So let me show you. This is, where did these signs go? Here's a little picture of a Ferris wheel and a stick figure having a really good time. You can see he's having a good time because his arms are up. You see it? He's like, wee. Yeah. And his legs are dangling. So this is a Ferris wheel, and the way that this problem is worded, they're not giving you any indication in the problem that he got on at a height that was different than the bottom, so we're going to assume that he got on at the very lowest point. And so we're going to say that if we were to label like the sides with our units, that the x-axis would be time. This is as time is passing throughout the problem. And then the y-axis is going to represent his height off the ground, like where he's at in the air. Okay, so it says you get on the Ferris wheel 4 feet above the ground. So if we can picture this, if he's getting on the Ferris wheel down here, there's like, there would be like another little person helping him get on. Maybe there's some sort of platform. So this would be 4 feet above the ground, and the Ferris wheel helper person is getting, loading the people onto the Ferris wheel 4 feet above the ground. So this is where he gets on, 4 feet above the ground. And then the very highest point is 84 feet above the ground. So I'm just going to say this is like the highest point, right? And we think about what happens. So as time, do you guys know if they go clockwise or counterclockwise? You go up. You go up first, right? You don't, but you go forwards. You don't go backward. You go backwards as you go down, right? Okay. Okay, so as you're riding the Ferris wheel, some time passes, and then you go like up in the air, right? And then usually as you get to the top, it feels like it kind of slows. Is that right? So it's like something like this, right? And then around the backside, you go down. Does that make sense? So if we look at this, and then you'd go down to where you'd be 4 feet above the ground. This is the bottom of the Ferris wheel. It would look something like that. And then you would keep doing that, right? So this would be one rotation around the Ferris wheel. You'd be down at the bottom again. But you don't usually do one rotation around the Ferris wheel, right? And then stop and they let you out. That's not usually how it goes. What do you usually do? You do several of them. I don't know how many you do, but it's like they load everybody up, and then you do a bunch of rotations around the Ferris wheel, and then your ride is over, and then they start to unload everybody. Does that make sense? So we would say this is sinusoidal because this would be like one rotation around the Ferris wheel, but then we would keep doing it. We'd like keep going. Oh, it froze. We would keep going around the Ferris wheel. Let me